Hello dear students, welcome to SW classes. Today I am going to solve exercise 1.2 of NCERT class 9th. As we have already solved the exercise 1.1, which you can see from the playlist in the YouTube channel of SW classes. So let's begin. So first question says, state whether following statements are true or false and justify your answer. You have to justify your answer also. So let's start. So first part of the first question says every irrational number is a real number. So let's we will check what is the conclusion of this statement. So as you already know that real number contains rational number and irrational number, so you can denote like this. This is real number, this is rational number, and this is irrational number. So as I have already discussed that real number contains rational number and irrational number. So you can say that every irrational number is a real number, or every rational number is a real number. So the statement was every irrational number is a real number. This statement is correct. This statement number 1 is correct. Now second statement. Second statement says every point on the number line is of the form root m, where m is a natural number. So this statement is regarding number line, which says every point on the number line is of the form root m, where m is a natural number. So let's see how this statement says. So suppose you have a number line like this. Here it's 0, 2, 4, 6, 8, 10, and so on. We have not written 1, 2, 3, 4, 5, 6. You can say that here it's 1, here it's 3. So you can see like this. And this side -1, -2, -3, -4, -5, -6, and so on. This side here it's 0. So the statement was every point on the number line is of the form root m, where m is a natural number. So you can say that this statement is wrong, because negative number, this minus 4, you can say that no negative number can be square root of any natural number, as no negative number can be square root of any natural number. Okay, just see 16, under root of 16 will become 4, under root of 4 become 2. So always the square root of any number is always positive. This square root cannot be negative. So the saying statement saying every point on the number line is of the form root m is incorrect, because we have a minus negative number also on the number line, so this statement is incorrect. Now statement number 3, every real number is an irrational number. Every real number is an irrational number. So we will check how this statement is. Just we have already discussed this type of, you can say that, just a second. So now statement 3, we will discuss it by example. So let us say irrational number example is pi. Let's have irrational number is pi, rational number is 1 2 3 4. These are rational number. So real number will become 1 2 3 4 5 6 and including this pi also. So statement, this showing statement every real number is an irrational number is incorrect, because we have real number as 1 2 3 4, which is rational number. The statement was showing every real number is an irrational number. This statement is incorrect. So this statement is incorrect. Now we will move on to question number 2, which says, question number 2, are the square roots of all positive integers irrational? Are the square roots of all positive integers is irrational? Let's check. As you already know that square root of a positive integer, just by example we will show square root of 81 is equals to 9, square root of 9 is equals to 3, square root of 16 is equals to 4, and so on. So square root of a natural number is a rational number. Here it's also a rational number. Here it's also a rational number. There are few numbers which square root can be irrational number. So statement was incorrect. Are the square roots of all positive integers is irrational? Here all positive integers square root can be, some of the numbers can be rational and some of the numbers can be irrational number. We have already shown you that square root of these numbers like root 81, root 16, root 9, and so many numbers are there. So these are rational number. 4 is rational number, 9 is rational number, 3 is rational number. So this statement was incorrect. So this statement is also incorrect. And if not, give an example of the square root of number that is rational number. So we have also given this example. You can write it down in your copy that root 81 has a square root equals to 9, that is rational number. Roots similarly, root 16 has a square root of 4, which is rational number. So now moving on to the next question, question number 3, which says, so how root 5 can be represented on the number line? So now we will represent root 5 on number line. So first we will draw a number line like this. Here it's 0, here it's 1, 2, 3, and so on. Here positive and this side it's negative, -1, -2 and so on. This is a number line. So we have to draw under root 5. So first we will draw under root 4. So how we will draw it? So first we will take this line from unit 0 to unit 1. We will draw a perpendicular on this line which is of 1 unit. Now this will become under root 2. This will become under root 2 because this segment was 1 square plus this segment is also 1, so 1 square under root that will becomes under root 2. Now we have found under root 2, so we will again draw a just a second we will again draw a 90 degree on this line. So we will find this one is 1 unit, so this will become under root 3 unit. Similarly we will draw a perpendicular on this side. This is perpendicular, so this will become under root 4. Just a second. Now we will again draw a 90 degree on this line, which will this is of 1 unit. Every perpendicular is of 1 unit. This is 1 unit, this is also 1 unit, this is also 1 unit, so this will become under root 5. This will become just a second this will become under root 5. So by following this you can solve this question. So let's again we will discuss it. First of all, I have taken 1 unit on the number line, then perpendicular on number line of 1 unit is this one. Just a second, we have to change this color. We have taken 1 unit here, so this will become under root 2 unit. Now we have taken perpendicular on this line as 1 unit, so this line will become under root 3 unit. So again we have taken a perpendicular on this line, so this will become under root 4 unit. This will become under root 4 unit, and again we have taken this line as perpendicular on this line, so this line become under root 5 unit. Okay, so now we will move on to the next question. Next question is classroom activity, constructing the square root spiral. Okay, this I have already discussed. So what is the question? Just say check. Classroom activity, constructing the square root spiral. Take a large sheet of paper and construct the square root spiral in the following fashion. Start with the point O and draw a line segment OP. Start from point O, then draw a line segment OP1. This is line segment OP1 of unit length. Unit length means 1 unit, 1 centimeter or 1 inch. You can take anything. So simply you can take 1 centimeter. Now draw a line segment P1 P2. This P1 P2 as 1 unit perpendicular on this OP1. Okay, so this will become under root 2 unit. Now again you have to draw a line segment P2 P3 on this line as perpendicular, so this will become under root 3 unit. Now again you can draw a line segment P3 P4 and so on, so square root spiral will be constructed. So this was your classroom activity. So this is the end of this video. Please do like, share and subscribe to our YouTube channel. If you have any doubt, please comment your doubts in the comment section below. Thank you.